In 1995, General Electric promised American railroads a monster. 6,000 horsepower from a single locomotive. The AC6000CW was supposed to be the ultimate weapon in GE's war against EMD, a machine so powerful it could replace two conventional units and revolutionize heavy freight operations forever. Railroads lined up to place orders. Union Pacific wanted them for the Powder River Basin coal trains. CSX wanted them for Appalachian coal drags. Everyone believed GE would deliver the future of American railroading. Everyone was wrong. Everyone remembers EMD's SD-90 Mac disaster, the 265H engine that destroyed locomotives, shattered trust, and accelerated EMD's collapse into the arms of private equity, and eventually, Caterpillar. History books treat it as a cautionary tale of engineering hubris and corporate neglect. Students in business schools study it as an example of how market leaders fall. But here's what the railroad industry doesn't talk about. GE had the exact same problem. Their 7HDL engine was just as flawed, just as unreliable, and caused just as much chaos for the railroads that trusted them. Brand new $6 million locomotives shook themselves apart. Engines that were supposed to run for years failed in months. Crews who expected revolutionary performance got revolutionary headaches instead. The difference? GE survived. EMD didn't. This is the story of how both locomotive giants bet everything on 6,000 horsepower and how one company's response to failure determined who would dominate American railroads for the next generation. The horsepower race of the 1990s wasn't about engineering pride. It was about survival. By 1993, American railroads faced a brutal economic reality. Train weights were climbing as carriers chased productivity gains. Coal drags routinely exceeded 15,000 tons. Intermodal consists pushed toward 10,000 tons. Every additional locomotive on a train meant more crew costs, more fuel, more maintenance, more capital, tied up in equipment that could be earning revenue somewhere else. The math was seductive. A single 6,000 horsepower locomotive could theoretically replace two 3,000 horsepower SD-42s. One crew instead of coordination between multiple units. One engine to fuel, one set of traction motors to inspect, one potential failure point instead of two. The railroad that cracked 6,000 horsepower first would have a massive competitive advantage. EMD moved first. In 1994, they announced the SD-90 MAC with their revolutionary 265H four-stroke engine. Union Pacific signed contracts immediately, desperate for power to handle exploding freight volumes. The pressure on GE was immediate and intense. General Electric couldn't let EMD own the 6,000 horsepower market, but they had a problem. Their proven FDL engine family, the workhorse that powered everything from Dash 8s to AC400CWs, couldn't produce more than 4,400 horsepower. The physics simply wouldn't allow it. To hit 6,000, GE needed an entirely new engine. They found their answer in Germany. Deutz MWM of Mannheim had been building industrial diesel engines since Carl Benz founded the company in 1871. The same Carl Benz who invented the automobile. The same company that had supplied engines for German industry through two world wars and the economic miracle that followed. When GE came calling in 1994, Deutz was developing a new electronically controlled diesel engine series for marine and stationary applications, massive power plants designed for continuous heavy-duty operation in ships and power stations. The partnership seemed perfect. German precision engineering combined with GE's locomotive expertise and access to North American markets. Deutz would design the engine core. GE would integrate it into their locomotive platform. Together, they would deliver 6,000 horsepower to American railroads before EMD could get their troubled 265H working properly. Together, they created the 7HDL16, a 16-cylinder, four-stroke monster with a 250mm bore and 320mm stroke. The engine displaced over 15,000 cubic inches, larger than anything GE had ever installed in a locomotive, larger than most marine engines of the era. Twin turbochargers force-fed air into the massive cylinders at pressures that would have seemed impossible a generation earlier. The rated output was 6,250 horsepower, derated to 6,000 for locomotive service to provide a theoretical margin of reliability. On paper, the 7HDL was magnificent. In reality, it was a ticking time bomb. The first AC6000CW rolled out of GE's Erie, Pennsylvania plant in late 1995. They called it the Green Machine for its distinctive paint scheme. CSX received the first 3 production units, numbers 600 through 602. Union Pacific got units 7000 through 7009 shortly after. All were released to their owners in late 1996, once GE's testing was complete. But GE's testing wasn't complete enough. The problems started almost immediately. Engineers at both CSX and Union Pacific began reporting issues that went far beyond normal break-in troubles. The 7HDL engine was shaking itself apart. The root cause was terrifyingly simple. The engine block walls were too thin. GE and Deutz had designed the 7HDL for maximum power density, but they'd underestimated the forces generated by 16 massive cylinders firing in rapid succession at 1050 RPM. The block couldn't handle the stress. Harmonic vibrations built up near the rated speed, creating resonance that propagated through the entire engine structure. Diagnostic analysis pinpointed the problem precisely. The engine's natural resonant frequency fell dangerously close to its normal operating speed. When the 7HDL ran at full power, it was essentially vibrating at its own destructive frequency. Every component bolted to the engine block absorbed those vibrations and transmitted them through the locomotive frame. The cab shook. The electrical cabinets rattled. Bolts worked loose, welds cracked. The vibrations caused cascading failures. Turbocharger mounting points cracked under the constant stress. Fuel lines worked loose from their fittings. Electrical connections shook apart over hundreds of miles of continuous operation. Components designed to last for years failed in months, sometimes weeks. The twin turbochargers, critical to feeding air into those enormous cylinders, were particularly vulnerable. They ingested the vibration and transmitted it back into the engine, creating feedback loops of mechanical destruction. Cooling system failures compounded the problems. The 7HDL ran hot under sustained load, and the locomotive's cooling infrastructure couldn't always keep up. Engines overheated during long pulls through mountain grades or across desert stretches in summer heat. Temperature warnings forced crews to reduce power exactly when they needed it most, struggling up a grade with 15,000 tons of coal pushing from behind. A CSX engineer who ran AC6000CWs out of Cincinnati described the experience years later. They rode horribly. CSX maxed the tonnage, and we only had the single unit. The vibration was intense as it would struggle to get the train up the hill. So glad when we went back to the normal 2 SD42s. 2 SD42s, 30-year-old technology, preferred over GE's brand new 6,000 horsepower Wonder. Union Pacific saw the problems coming and made a decision that would prove either brilliant or cowardly, depending on who you asked. UP was desperate for power in 1995. They couldn't wait for GE to perfect the 7HDL engine, but they also couldn't afford a fleet of unreliable locomotives sitting in shops while freight piled up in yards, so they proposed a compromise. Give us the AC6000CW body, the frame, the traction motors, the electrical systems, but install the proven 7FDL engine instead of the troubled 7HDL. GE agreed. Between August 1995 and April 1998, they built 106 convertible AC6000CWs for Union Pacific. These units had everything needed for 6,000 horsepower operation except the engine that could deliver it. The 7FDL was rated at 4,400 horsepower, a far cry from the promised 6,000, but reliable. The plan was simple. Run the convertibles with the smaller engine until GE fixed the 7HDL problems, then swap in the powerful prime movers and unlock the full 6,000 horsepower. Union Pacific classified these units as C6044, ACS, or AC4460CWS, acknowledging that they were 4,400 horsepower locomotives wearing 6,000 horsepower bodies. The conversion never happened. CSX, meanwhile, refused to compromise. They wanted the full 6,000 horsepower they'd paid for. CSX ordered 117 AC6000CWs, and every single one came with the 7HDL engine. They would live with the consequences of that decision for over a decade. GE's response to the crisis revealed the difference between a company fighting for survival and a company fighting to maintain dominance. EMD, facing identical problems with their 265H engine, was paralyzed. General Motors, their parent company, was bleeding cash in automotive losses and saw the locomotive division as a distraction. Engineering budgets got slashed, problems festered. The SD90 MAC program collapsed into chaos, and EMD's reputation collapsed with it. GE took the opposite approach. They threw resources at the problem. Engineers in Erie worked to understand the vibration issues. They discovered that increasing the engine block mass could lower the resonant frequency, moving it away from normal operating speeds. But adding mass created new problems. The heavier engine stressed the turbocharger mounting points even more. GE had to redesign the turbo installation to handle the increased weight. They stiffened the block walls with denser materials. They thickened critical sections to add mass exactly where it was needed. They refined the mounting systems to isolate vibrations before they could propagate. Component by component, failure by failure, they addressed the engineering shortcomings that should have been caught before the first locomotive left Erie. Full production didn't begin until 1998, 3 years after the first units were delivered. By then, GE had incorporated the fixes into the production line. Later, AC6000CWs were significantly more reliable than the early units, though they never achieved the bulletproof reputation of the AC4400CW. The damage, however, was already done. By the time GE fixed the 7HDL, the market for 6,000 horsepower locomotives had evaporated. Railroads had done the math differently now. Yes, a single 6,000 horsepower unit could theoretically replace two 3,000 horsepower units in raw pulling power. But what happened when that single unit failed? Instead of losing half your power, you lost everything. The entire train sat dead until relief could arrive. Dispatchers had to scramble for replacement locomotives. Schedules collapsed like dominoes. The theoretical savings from running one unit instead of two evaporated when that one unit spent half its time in the shop. The operational risk wasn't worth the capital savings. There was another problem nobody had anticipated. The locomotives were too powerful for many applications. 6,000 horsepower was overkill for most freight trains. Running a 6,000 horsepower unit at half power wasted fuel and increased wear on components designed to operate under full load. The engines ran inefficiently. The fuel bills climbed. The maintenance costs mounted. The sweet spot for freight operations turned out to be somewhere between 4,300 and 4,500 horsepower, exactly what the AC4400CW already delivered. That locomotive, introduced in 1993, proved reliable from the start. It offered enough power for virtually any freight application without the complexity and risk of the 6,000 horsepower designs. Railroads that had lusted after the AC6000CW started ordering more AC4400CWS instead. CSX and Union Pacific stopped ordering AC6000CWs. Production ended in 2001 with just over 300 units built, a fraction of the thousands GE had projected during the horsepower race's optimistic peak. The investment in developing the 7HDL, building the production lines, training the service network, all of it wasted on a product the market no longer wanted. The AC4400CW, meanwhile, sold nearly 3,000 units and became one of the most successful locomotive designs in GE's history. It wasn't as powerful as the AC6000CW, but it worked every single day without shaking itself apart. The 6,000 horsepower dream was dead. Both GE and EMD had chased it. Both had failed to deliver reliable products, and both had learned the same painful lesson. Railroads valued reliability over raw power. A locomotive that ran at 4,400 horsepower every day was worth more than one that promised 6,000, but delivered only headaches. But only one company survived to apply that lesson. The aftermath revealed GE's true advantage over EMD: deep pockets and patient customers. Union Pacific's convertibles, the units that never got their engine upgrades, remained in service for decades. They worked coal trains in the Powder River Basin and rock drags in Texas, running reliably with their 4,400 horsepower FDL engines. The locomotives were overbuilt for their actual power output, which ironically meant they lasted longer and needed less maintenance than units working at their design limits. The massive frames and generators designed for 6,000 horsepower loafed along at 4,400, barely breaking a sweat. The 7HDL-equipped units required more aggressive intervention. Union Pacific eventually repowered their HDL locomotives with FDL engines, creating an entire fleet of 4,400 horsepower AC 6000CWs that would never deliver the 6,000 horsepower they were designed to produce. It was an expensive admission of failure, but it kept the locomotives productive and earning revenue instead of sitting dead in storage. CSX took a different path. Rather than downgrade to the older FDL engine, they upgraded to something better. In the early 2000s, CSX began repowering their AC6000CW fleet with GE V016 engines, GE's next-generation prime mover that would power the successful ES44 series. These rebuilt units, classified as CW46AHS, were capable of 5,800 horsepower, but rated at 4,600 for operational reasons. The irony was bitter. CSX had held out for the full 6,000 horsepower. They'd endured years of reliability problems, intense vibrations, and operational headaches. In the end, they got 4,600 horsepower locomotives that worked reliably, exactly what they could have had from the beginning with AC4400CWs. 8 AC6000CWs escaped to Australia, and they wrote a different ending. BHP Billiton ordered the units for their iron ore operations in Western Australia's Pilbara region. The locomotives were modified for the brutal conditions. Enhanced air filtration to handle the red dust that coated everything, improved cooling for temperatures that regularly exceeded 40 degrees Celsius, steerable trucks for the heavy ore cars they'd be pulling. On June 21, 2001, all 8 BHP AC6000CWs combined to set a world record that still stands. They hauled 682 ore cars loaded with 82,000 tons of iron ore, a gross train weight of 99,734 tons. The train stretched 7.3 kilometers from the lead locomotive to the end-of-train device. They pulled it 275 kilometers from the Yandi mine to Port Hedland without incident. For one day, the AC6000CW delivered on its promise. 8 locomotives doing the work that would have required a small fleet of conventional power. The record proved that the concept was sound, that 6,000 horsepower could transform heavy haul operations when properly applied. But even the Australian units couldn't escape the 7 HDL's reputation. BHP eventually replaced all 8 with EMD-SD70ACES. Despite their historical significance, the AC6000CWs were scrapped in 2014 when BHP couldn't find buyers willing to deal with the maintenance demands of the troublesome engine. The final chapter of the AC6000CW story is still being written. By 2024, CSX had scrapped or sold almost their entire fleet. A few units went to short-line railroads, 8 found homes on the Western New York and Pennsylvania Railroad, though traffic changes rendered them surplus by 2024. One became a rolling entertainment car for the Aberdeen, Carolina and Western Railway, its engine compartment gutted and converted for guests. The locomotive that was supposed to revolutionize heavy freight is now a party car. Union Pacific held on longer. Beginning in 2018, they sent their remaining AC6000CWs to Wabtec for modernization. The rebuilt units, classified as C44A CMS, received updated electronics and systems while keeping their 4,400 horsepower ratings. By 2023, all surviving Union Pacific AC6000CWs had been through the program. Only 2 units have been preserved as museum pieces. Wabtec donated GECX6002, originally Union Pacific 7511, to the Lakeshore Railway Museum in Pennsylvania in 2022. It was the first modern AC traction locomotive to enter preservation, a dubious honor for a machine that never lived up to its billing. The AC6000CW disaster should have destroyed GE the way the SD90M AC destroyed EMD. Both companies rushed unfinished engines to market. Both promised 6,000 horsepower they couldn't reliably deliver. Both damaged relationships with their most important customers. The difference was institutional strength. GE Transportation was part of a massive conglomerate with resources to weather the storm. When the 7 HDL failed, GE could afford to redesign it, repower the failures, and develop the GEVO engine that would dominate the next generation. They had the engineering depth to fix problems and the financial reserves to survive while they did it. EMD had none of that. General Motors was already struggling when the 265H disaster hit. The locomotive division got treated as a distraction rather than a priority. Engineering budgets got slashed when they should have been expanded. Quality control collapsed. The death spiral accelerated until GM sold the division to private equity in 2005 for a fraction of its former value. Both companies made the same mistake. Only one had the resources to recover from it. Today, if you watch a coal train climbing toward the Powder River Basin or an intermodal consist racing toward the Pacific, the locomotives pulling it almost certainly came from GE or Wabtec, which acquired GE Transportation in 2019. EMD survives as a subsidiary of Caterpillar's Progress Rail, holding roughly 30% of the North American market. The horsepower race ended without a winner. 6,000 horsepower was too much for most applications, too unreliable in its initial implementations, and too risky operationally. The locomotives that dominate American railroads today, the ES44AC, the SD70ACE, deliver between 4,400 and 4,500 horsepower. The Goldilocks zone that engineers discovered in the aftermath of the 6,000 horsepower disaster? GE's secret shame isn't really a secret. Engineers who lived through it remember the vibrations, the failures, the embarrassment of watching brand new locomotives get towed back to shops. Rail fans who chase trains today know that the few surviving AC6000CWs are running with different engines than they were designed to use, their 6,000 horsepower promise permanently unfulfilled. But history is written by winners. EMD's SD90 Mac disaster gets studied as a cautionary tale of corporate failure. GE's AC6000CW disaster gets forgotten because GE is still here, still building locomotives, still dominating the market they almost lost. The lesson isn't that GE was smarter than EMD. They made the same mistakes. They rushed an unfinished engine to market. They promised performance they couldn't deliver. They damaged relationships with customers who had trusted them for decades. The lesson is that survival in industrial competition isn't about avoiding failures. It's about having the resources to recover from them. EMD bet everything on the 265H and lost. When the engine failed, they had no backup plan, no engineering reserves, and no corporate parent willing to invest in fixing the problems. General Motors wanted out of the locomotive business, and the 265H disaster gave them the excuse they needed. GE bet everything on the 7HDL, also lost, and had enough chips left to play another hand. They fixed the engine. They developed the GEVO that would power their next generation. They maintained relationships with customers by offering solutions instead of excuses. They survived because they could afford to survive. The trains still roll, the freight still moves, and the AC6000CWs that were supposed to revolutionize American railroading have mostly been scrapped, rebuilt, or converted to party cars. Monuments to a dream that both companies chased and neither could deliver. 6,000 horsepower. The goal that destroyed one company and nearly destroyed another. The disaster nobody talks about because the company that survived it would rather you forget.